Hi there, this is my first YouTube video. Hope it goes well. This video will be about getting a VFD to work with lathe controls. I struggled with it primarily around how to control the motor, but let's get into it. So I'm going to show you first, actually the first thing I want to do is warn you about electricity, so you'll see that everything's turned off. The reason for that is if you're mucking around with electricity, do it when things are turned off. And this is the reason why.
I say there's the possibility of electrocution. Do you understand?
I understand. Why are you shouting?
So what we're going to do is we're just going to cover turning it on and how the controls work initially. I'm then going to show you a diagram of how the controls work, a circuit diagram type thing. It's fairly simple, so don't get nervous about that. And then I'm going to take you through how the switching works behind each of these various controls. So just dealing with the controls first, we've got an on-off switch here, which is a master on-off for the lathe. We've then also got a big lever and a small lever that control whether the chuck goes round or not. And this little lever controls whether it's in reverse. So let's plug it in and see how stuff is working at the moment with the lathe controls. There's only a couple of things here really that I need to change on the front. So I've got this set to off at the moment. I need to turn that on. And then to get the chuck spinning, I pull this lever up. And based on where the smaller lever is, that will determine whether it goes forward or reverse. So it's going one way at the moment. Turn it off. Change the small lever. And it goes the other way. Now if I turn it off down here, that's loose. I'm going to show you what's behind there in a minute. Turn that off, nothing will work now. And that's because what you have to do when you're thinking about this project is there's two aspects to how the VFD works. One is the three-phase output of electricity. So that's one mechanism, and there's some controls, or there's some inputs on the VFD that I'll show you now where that output goes. Here we have a schematic from the VFD manual that outlines how the wiring works for the 220 that goes in through L1 and L3. The output for the three-phase 220 goes out through T1, T2, T3. The motor needs to be wired in delta to facilitate that. The other aspect of the VFD is the control circuit. So the motor gets wired direct into the VFD. So there's no switches, there's nothing between the VFD output and the motor. That's just a direct wire. There's a control circuit that runs from the VFD. So if you have a look here, on these options here. Here we have a sketch from the VFD that outlines how the low voltage circuits work. And we're using forward, reverse, and the 12 volts, so that's 3, 4, and 5. And we're also going to end up using 8, 9, and 10, which is for the potentiometer. When you use these circuits, you have to go into the VFD and notify it that you're using switching instead of using the front panel on the VFD. That was another error I made. If you don't do that, nothing works. The way to think about this is like wiring a light. So you've got a lighting circuit here. And you've got a battery, you've got a wire that comes out, hooks up to the light and goes back to the negative. And in a lighting circuit you've got some switches, usually just an on-off. That's all we're doing here, except we've got a couple more switches. We have a switch here to turn the lathe on and off. We have a switch here to turn the chuck on and off. So what we're doing here is we're trying to get the control circuit from the lathe back to the VFD. So the overall where things are going is we're taking the 12 volt from the VFD into the lathe, into this rotary switch, it then goes, the yellow wire goes to the back of the lathe, and then it goes back to the VFD. So when we've got things here, when this is turned on, this goes one way, because the rotary switch is set one way, and then goes the other way. So this switch at the rear of the machine was one of the first mistakes I made. I thought I could just wire T1, T2 and T3 from the VFD direct into this. And even though I had all the switches open, including this one, the contactor, which I'll be showing in a little bit, wouldn't activate, so nothing on the lathe worked. That's what this looks like inside, and you can see that it's fairly clear that where the three-phase goes in, so it was logical, I thought, to just wire T1, T2, T3 in there. But as I said, it just doesn't work, so don't do that. But this rotary switch has got about 9 connectors on it, and each of them are labelled in the same way. So they're labelled 1, A1, A2, 2, B1, B2, and 3, C1, C2. And the way they work is that when you turn this thing to on, 1 and A1 will work, and the same for the other ones. So I'll cover this in a diagram that I'm about to draw. And I figured all this out through using a multimeter and just figuring out where continuity was on the switch at the different settings. So this is a continuity meter here, and each of them usually has a little indication of sound on it. On this one, you need to turn it to that sound indication, plus you need to press the function button. Let's just test we've got continuity. Okay, so I know that meter's working, it's beeping. So at the moment I have the switch off, and this terminal here is A1 and this one is 1. So if I put the continuity meter like this, beeps. If I put it on A1 and 1, it doesn't. If I turn the switch on, I've got continuity. So that's important because I need to make sure that the 12 volt circuit here that's coming from the VFD, that's the 12 volt there, is going right through this rotary switch and coming out this yellow wire, and that goes to the back of the machine, a square box in the back of the machine, and you'll see that shortly. So the switch is on now, so let's check if we've got continuity between 3 and C1. That's the switch circuit I'm using. We have, so that means I've got the 12 volt to the back of the machine. Let's go and have a look at that. The large lever that's at the front of the lathe, this controls this switch here. So when I move it, let's just double check everything's off. Yep. You can see that moves this here. So what's happening is that yellow wire that I've talked about earlier, that's at the front of the machine, that's where this comes out. So I've run the 12 volt through to the on-off switch, the rotary switch at the front of the machine, and now it's to here. When I move that up, that forms a circuit. So I've now got the electricity to here, and it comes out on this terminal here. Now this wire here, this with the yellow sheathing, and now to form the complete circuit I've got to run a wire from here up to this rotary switch here. Now there are a couple of videos on YouTube that indicate that there is continuity between this switch and this switch. There wasn't any on this lathe, and all I can determine, or all I can think of, is that because this lathe was 3-phase, it didn't require it. The other lathes were probably single phase. So now I've got 12 volt to here, and based on where the small lever that was at the front of the machine is, that will determine whether it goes in forward and reverse. So I need to have a wire for forward and a wire for reverse, and these wires both go back to forward and reverse on the VFD. Now that completes the circuit. So this diagram will show you how that circuit is being completed. So this is the section of the video I wish I'd had when I was doing this all initially. What we'll cover here is how the physical lathe controls on the outside of the machine look, and then we'll cover the switching that relates behind those machines. So all I'm doing here is drawing out the various controls. We've got the on-off switch at the rear, another on-off and motor pump switch at the front. The big lever and the little lever. Big lever turns the chuck on. The little lever determines whether it goes forward or reverse when the chuck is moved. Now the switches behind these, we've got the original on-off switch. Don't need that at all because we're going direct. Then we've got the rotator switch, which you've seen as well. We don't need the contactor, but we do need to use the two switches at the rear and the machine, the square one and the round one. Square one's for the big lever, little one's for the rotary switch. So how are we going to end up wiring this up? We're going to take 12 volt from the VFD and we're going to run that through to the rotary switch, connector 3 and C1. Then the yellow wire goes to the back of the machine, big square box. Take another wire to the little circular box, forward and reverse, and then run a couple of wires off that will go back to the VFD respectively for forward and reverse, depending which way around they are. And it really is that simple. That's why I use the light switch analogy. When you draw out a diagram, it becomes pretty basic. This next section shows the rotary switch, and depending on its position, it's what contactors are active. And I'm just going to end up using U, R and S. So I put the 12 volt to the U and the forward and reverse to the R and the S. Now, in doing all of this, I did make a few mistakes. First one, the biggest one, is make sure the motor is absolutely directly wired to the VFD. No switches, no contactor, nothing, just direct to the VFD. Next mistake was just the lathe safety switch. I took the cover off the engine gearing. That activated a circuit and the yellow wire stopped working. That made me think some things were broken. The forward and reverse wiring I just was talking about before, I wired the 12 volt initially both to U and V, so the VFD didn't know whether it was going backwards or forwards. It just needed one input on the left hand side there. My motor was also needed to be rewired from star to delta because I had a dual voltage motor. That was a big mistake. It took me a while to figure that one out, and the top gear of the lathe didn't work as a result of that. Next thing was I bought a tachometer from China, opened it and lost the magnet, so I had to buy another one. And the last one was just remember to change the software settings in the VFD so that it knows whether you're using switching or the main control panel on the VFD. This is some of the detail of one of the mistakes I made. This motor here is wired up as star, and you can see the wee diagram down the bottom right. 3 of those yellow connectors are all going to the same terminal. Now they're actually labelled as B2, C2 and A2, and that tells you how to wire it up as delta. And what I hadn't realised was because I had a dual phase motor, but I bought a 220 output 3-phase VFD, I needed to rewire this motor for delta. So I just changed those 3 yellow wires and put them onto the other terminals as per the diagram, and then that all worked correctly. This is just a small dial lever. You can just twist this around, and this will also control the speed of the lathe. So I've increased the speed at the moment. I've put it on faster. So if I look at it now, so the way that's wired is these 3 wires on the VFD. Here is how the potentiometer is wired up. We've got 3 wires that correspond to 8, 9 and 10 terminals on the VFD. The 10 volt is directly labelled, so that's just 1-to-1, and the 0 volt is the ground. Don't forget to change the VFD settings so it knows that there's a potentiometer attached. Here we have a diagram that shows the various parameters that we can change on the VFD menu. Just read through the instructions on your VFD panel. On this one, you've got to press display function a couple of times. You get to the entry, press data, it will display what data is there. You can use your up and down arrows and then change stuff. So this is important to make sure the VFD knows it's using switching, not using the VFD panel directly. If you don't do this, nothing will work. A couple of things that will be useful to explain as well. This is what's called a contactor. So hopefully you can see that. There's a small magnet here, and this particular device was in here. Now what I realised was I took it out, and there are a couple of YouTube videos along these lines where they take the contactor out and they put the VFD inside behind here. And I must admit that's why I took the contactor out. But what I've realised subsequently was really all I needed was that yellow wire, so I could have left all this in there. I have labelled it up, so if anyone wants to put this machine back to 3-phase they can, but the reason this isn't required is the VFD would not power this contactor and it would not activate this magnet. So that's one of the primary reasons why you need to wire the VFD direct into the motor. The contactor is no good, it doesn't do the job. The other thing that I've done to save a bit of money is I'm just running one VFD, but I've got these two other machines, the sander and the donkey saw thing. And what I've done is I've used the same wiring approach, an on-off button, and running that 12-volt control circuit, and I've achieved that through this here. So I got these plugs. Let's have a look. Yeah, let's see. So that's a 9-pin plug. That's the other side of it there. You can see. Let's get this out. There. So I wired up all those control wires using these 9-pin plugs, and that just means I can just unplug the 3-phase output from the lathe and the control wire, and if I've run something similar wiring for the donkey saw and for the linisher, it means I just save some money. So we've got a few other things working on the lathe. We've got the tachometer on, we've got the emergency stop button, the potentiometer you've seen before. This is all going to be mounted somewhere up like this on the lathe, probably more of it there. What we've also done is, for the tachometer to be installed, we've had to, I've just got it, let's just have a look here. That's just rigged up with some duct tape at the moment, just there, just as a temporary measure. So if we test this out, I've got the lathe set to rotate at 1200 RPM at the moment, that's on the gears. Let's just see how accurate the lathe is with the tachometer installed now. Not sure if these things warm up, but it did seem to get a bit faster. When I press the emergency stop, that's then stopped the whole thing. Let's try it on one of the lower speed settings as well. So I'll put it down to, I'll halve the speed by changing this lever here. I have to put the lever down to reset it, and then I have to reset the stop button. There we go. So this should run at 696 with this lever in this position. Let's see if that's right. So that's good, that's running exactly the right speed. The top gear's working okay, so I think this lathe is working okay. The stop button here, you press it down and then you turn it to release. And originally this had a normally closed contactor in it, which was not what the VFD was expecting. It was expecting a normally open circuit. So to get this normally closed one to work, I wired this in the 12-volt circuit. So I ran a wire from 12 volt here, and then I continued the 12-volt wire onwards. And what that meant was that when I pressed this down, it broke the circuit, and instead of becoming normally closed, it became normally open, and that just stopped the 12 volt. Didn't know what it was doing. But to wire this in the standard way that the VFD was expecting, I changed this contactor in here. I just bought one off RS Components, and I changed this to a normally open contactor, which meant I could use the VFD in the standard way. Let's have a look at how the wiring for this tachometer works. So it's based on DC. So this is just a standard adapter that you can buy off Amazon. A 12 volt output. That just goes into a simple adapter here. So there's 3 wires in the cable that runs off to the lathe. Yeah, there's 3 wires that go off to the tacho measuring sensor. The brown, blue and black. So what I've done to get the display to work is I've wired up the brown with one of the LED sensors that was labelled brown and power. So I've taken the plus from here and just put them together. I've taken the blue and the white cable. So the white one that goes back to the tachometer is labelled blue, so they've been commoned up. They go to the negative on here. And the black cable just goes direct from the measurement device on the lathe to the 5th terminal white wire on the tachometer. So the tachometer has just been stuck on with duct tape, and there's a magnet on here. The only thing to be aware of is that if you put the magnet round, there's the magnet just there, if you put the magnet round the wrong way, effectively the polarity will be wrong and it won't register. That's about the only thing that's tricky there. I have got some other videos that will be coming out because I'm doing a restoration on this donkey saw, and I'm also doing I've also wired up a linisher, a sanding machine. The reason there's a couple of videos on that is it's also going to explain how to wire motors from star to delta as well, because that was one of the mistakes which I've covered in this one, but there'll be a little bit more on that in another video. So I've shown you how all the wiring works, taken you around. The biggest thing I can say is just do a simple sketch of how you want this 12 volt wire to run through the various switches. So here we take 12 volt from the VFD through to this on off button here. It then goes through that yellow wire to the rear of the machine. When this is lifted up, that square box engages. The rotary switch then has got the forward and reverse depending on which way around this lever is, and that forward and reverse takes the wire back to the VFD. It's that simple. That's the whole circuit, and that would have really helped me if I'd had that outlined when we started this when I started this journey. I hope you find this video of some use, and if you do, hit that subscribe button and like it, just the usual stuff. A couple of the up and coming videos are going to describe how we restore this old lathe and this donkey saw here. That was a bit of an effort. Anyway, hope you enjoy the videos. Like and subscribe, and keep on watching. Thanks.